Hello and welcome to the 19th Caithness International Science Festival. We're delighted to welcome you tonight at this, the final instalment of the 3 events from Caithness Astronomy Group that are helping us to get to know our celestial neighbour, the moon, a little bit better. I'm Gareth Warburton, Science 03 committee member, and here with me tonight is Nicola MacLeod, the festival coordinator, and joining us from Caithness Astronomy Group are Professor Keith Nicholson, who will deliver the featured presentation, Gordon Mackey, Neil McLean, Christian Wilhelm, who, weather permitting, will be carrying out the live observations, and John Hilton and Ian Darby, who will be moderating and assisting with the Q&A. Before we begin, a little bit of housekeeping. The event is being recorded, however, your screens are not. This has been a popular event, so please direct all your comments, feedback and questions through the Q&A, and we will answer as many as we can. As an audience, you have the opportunity to upvote questions, so if there's a question someone else has asked that you are keen to hear the answer, give it the thumbs up and it will move it up the list. I'm now going to hand over to Professor Keith Nicholson for tonight's presentation, The Moon, Part 3, The Far Side of the Moon. Thank you.
Thank you very much, and welcome everybody. Thanks for coming along. I shall just share my screen and start the slideshow. So you'll have some of you will have attended the first 2 events from Friday and Saturday. So this one is our 3rd event. We're going to have a look at the area of the moon that you can't see. So the far side of the moon. And we'll take a look at some of the images of that. And if time permits, we might have a look at some of the geology, because we've had a few geology questions as well. But members of the group are out. We've got 3 telescopes out, different areas of Caithness at the moment. It's not looking very helpful in terms of the cloud cover. It's wonderful earlier on, but if it does get a break, then I'll break off speaking and we'll start to look at some real images of the moon, which I think will be more interesting than listening to me. So I want to show you some views of the far side of the moon. Obviously, it's the area you can't see. So I think it'd be quite interesting just to compare it with the side of the moon that you can. And this first image I'm just showing you right now, there are 2 things that I think are really striking on it. Firstly, just how many craters there are compared to the near side that we can see. And secondly, just how the lack of really dark areas, the basalt mariner areas that are so dominant on the near side of the moon, which we had a good look at in the last 2 talks as well. So I'm going to take you through some of these images that we've had recently from the Chinese Chang'e 4 probe, and then we'll maybe take a look at the geology, and if we've got time, we'll look at some of the very early images from the 1950s probes that were there. So let's take a look firstly at Chang'e 4, this Chinese probe that was launched in December 7th, 2018. It's composed of there are 3 components to it: the lander, the rover, and a satellite that orbits the moon as well. And if we just take a look at these, so you can see, if we just take a look here, here's the lander. The rover is held within the lander and it deploys once the lander's landed on the surface. But the key to the success, really, into obtaining the images is this satellite that's in orbit. Now, clearly, any communication, the radio waves, for example, need a line of sight, and the moon gets in the way of that if you're on the far side. So to be able to transmit these images, we need a satellite in orbit to act as a relay, both from the lander and the rover, that relays back to the station on Earth. And if we didn't have that satellite, then it just wouldn't be possible to have that communication. As the Apollo astronauts found when they went around the moon, NASA lost communication with them for some time until they re-emerged from the far side. So we've got that communication now, and I thought it's quite helpful just to start by looking at the landing sites. Now, Gordon has shown you some in the earlier talks, and you can see the dominant areas in which they've landed. This doesn't include, by the way, the very latest Chinese probe, which was up in this area here. But the majority of them are American, some from the old Soviet Union, and increasingly China and indeed Russia are starting to come back and look at the moon in great detail. The only landing that has been on the far side is Chang'e 4, and that's what we're going to take a look at and have a look at this landing area as well. And you can see in this false color image that's a bit like a relief map that you might see in an atlas. It shows the low areas in blue and the higher areas in red. And what is most striking is you saw that on the very first picture I showed you, you saw this area here quite distinct. But what was less obvious was this large basin area, big impact crater. And we'll have a look at that in some detail. So here it is again. Here's that image with the large impact basin. This is a close-up of it with the various craters named, and again you can see the relative topography, the relative height of these areas. And this is the area in which the lander landed in this von Karman crater. It's a giant impact, or within a giant impact basin. And you can see it just here. This is where the Chang'e probe landed. So a few features then about this extraordinary impact area. It's the Aitken Basin. It's about 1,500 miles across, and it's by far the largest impact crater known in the solar system, or one of the largest in the solar system, and the largest on the moon. It's approximately 3.9 billion years old. Now, if you remember from Gordon's talk, the moon is about 4.5 billion years old. So this impact crater happened when the moon was still relatively active in terms of geological activity. Impact and real significant geological event at that time. It's thought that the asteroid that impacted it was about 170 kilometers wide, so huge impact on that. And if we look a bit more detail at the crater, then what we can see is some various features on this crater, and we can zoom in. This is a little section here that zooms in a little bit further. And the lander, which is, and you can just see it here in this little dot in the bottom right hand side, that was taken from an image from orbit. You can just see that it's within really a relatively smooth plain area within this large crater. And it's the purpose of this rover was obviously, like most rovers, just to transverse this area and go and investigate some of these craters. So this is the Chang'e 4 landing area, and this sharp crater here that you can see, it's nearly 4,000 meters across and 600 meters deep. So these don't look much on this image, but there are actually really quite large features, quite extraordinarily large features within this absolutely massive crater, which is in itself within this massive impact area. So the scale of these things is really quite extraordinary. If we take some of the images that were taken by the lander rather than the rover of its landing site, you get again this impression of this largely grey terrain. It looks a little bit flat, a little bit featureless, but as we saw in that last image, some of the craters in there are really quite significant. And in the bottom right here, you can see the tracks of the rover as it was deployed from the lander. Now, we've known really from the Apollo missions that the surface of the moon is really quite dusty, and hence the tracks that Gordon showed you those images yesterday on the moon. That's why they're there, and of course there's no wind to erode them, so they remain in place. But that dust did prove some challenges to the Apollo astronauts in terms it's very it clings to everything, and the astronauts found it quite difficult to remove it from their spacesuits before they re-entered the landers. And of course, for a rover, it could cause some real difficulties in terms of clogging the wheels. Imagine spinning in mud on the tires on your own vehicle. So the tires or the wheels have been designed so that doesn't happen. And you can see here on this wheels, it's designed to roll over that dust without it clogging and eventually preventing the rover from moving. And here's some more images from the site. Another crater, a little bit of a smoother side to the edge of this, but again very significantly deep. And the whole terrain is not as smooth as you might guess from some of those pictures. It's still quite rocky, still quite significant boulders. And here's some more tracks on this bottom picture of the rover. And I quite like this one because it looks like it's just done a handbrake turn there, which sounds like somebody having a bit of fun with the rover there as they're sending it along on its journey. But let's not forget about the satellite that's in orbit, and that is doing work as well. It's not just the relay satellite, it's taking images. And I find these two images really quite striking. The orbit outside the moon is quite significant, and it allows it to take some images of both the moon and the Earth. And I think these are just really quite evocative images, seeing the two, the planet and the moon together there. And again, in this lower image, it's just that the satellite's closer to the moon in this one. And again, you can see the Earth and the moon. And I think these are really quite emotional, really quite extraordinary images to see the two bodies together in space. So let's take a look at the geology of the moon in at least in outline. There was a few questions over the last couple of nights about the geology, so I thought we might just take a bit of a survey of it. You might recall that the Apollo missions left various instruments on the moon that operated for a long time. In fact, I think some are still operating, and that seismographs there were able to identify some of the structure in the moon. And as on Earth, we've got a crust, a very thin crust, around about 65 kilometers, so comparable in thickness to that of the Earth, a mantle and a core. And then the core itself is divided into different sections. But the key thing that we really need just to think about is that the core, as we said last night, is really an iron nickel or iron rich core, which we see typically in planetary bodies like this. There may be some fluid, it may be slightly liquid at the very, very center. Not absolutely certain, but it's certainly not very significant if it is the case. And the evolution of the moon we touched on in the past, and it's really quite extraordinary. And I've put here some links to more detail about this and some really good images, which you can take a look at when you get copies of the slides. But initially, after the impact of a body, probably about the size of Mars, into the early Earth, separated out, fragmented a lot of the material that came to form the moon and again coalesced into the Earth. And in the early stages of the moon, it was just a big ball of magma. Just imagine the volcano eruptions that you see from Hawaii and elsewhere. It was just this big ball of molten rock. And it eventually cooled and formed a crust. But lava eruptions from the lava that's just below the crust still continued. And they continued till about 3 billion years ago. So if you think of the moon forming about 4.5 billion years ago, there was about 1.5 billion years of volcanic activity. And it's in that period that we see the erupted so-called seas or the marina, those basalt areas that we see so much of at the near side of the moon, but not so much on the far side. And I'll talk about that in a minute. So around about 1 billion years ago, the moon cooled and has really to become like it is today, not active at all. In fact, the last real eruptions were well before 1 billion years ago. But over that time, of course, the moon has exerted a drag on the Earth. The tidal pull, the gravity pull on the Earth has had an impact. And it's had an impact in increasing the length of the day from 18 hours about 1 billion years ago to 22 hours 370 million years ago. And that's the age of the rocks that we see in Caithness. So the Dunnet Head and Orkney, they're all deposited around about that time. And of course, today it's 24 hours or almost 24 hours. But I thought you might like to see some images of the rocks and the minerals that form the moon on both its sides. And as I say, it formed about 4.5 billion years ago. And that crust formed quite quickly after that, so within the first billion years, probably 500 million years. And the crust is different from the depths of the moon because it's composed of different minerals. So if you think of heavier minerals sinking and lighter minerals floating on the magma ocean, that's pretty much how the moon was in its early stages. And the lunar crust is quite light. Remember, it's that grayish color mostly, apart from in the basalt areas, which tend to be a little bit bluish because of the different mineral structure. We can talk about that in a minute. So most of the crust is formed of a feldspar mineral, called plagioclase feldspar, and these are very light colored. If you see some large crystals of granite, the light crystals in the granite, not the quartz, but the ones that are white rather than that translucent color, tend to be plagioclase. And the lunar crust is primarily composed of plagioclase crystals. And these are images from the Apollo missions, about 4.5 billion years old. You can see again this lighter color, this plagioclase feldspar that formed on the very crust of the moon. And it formed all the way around the moon, far side and near side as well. And let's just these plagioclase feldspars in the bottom right here. If we take a thin section, so around about 1 millimeter thick or less of rock, and put that under polarized light, plagioclase feldspars are really beautiful. They have this zebra stripe to them. There are different types of plagioclase feldspar, and they have different patterns of zebra stripes. But the key thing is they're very easy to identify. And by contrast, if we look at the basalts, those darker areas, the lava flows on the moon, they're composed of different minerals, one of which is olivine. And this is a crystal of olivine in thin section, this trapezoid lozenge shape. Olivines, when they're quite large, look very green. And we were talking last night about the different tinges of color to the rocks. And if you've got a large amount of olivine in it, and it's not completely fine-grained, it's sort of around about 1 millimeter, so it gives a tinge of greenish color to the rocks. And the other minerals that we find in the mantle and in some of these lavas as well are pyroxenes. We don't need to look at all these different types. You can look those up later if you wish. But these are quite darker, as you can see in this thin section. And again, give a brownish or greenish color to the rock. And these are some very large crystals. This is not from the moon. This is an example from Brazil, which has some extraordinary examples that you can buy if you want. So let's take a look. So that's a bit of background on the geology of the moon in general. Let's take a look at the far side again. Well, we know that about just over 1/3 of the moon, which is the side that is facing the Earth, is covered with these marina lavas. flows, the seas, if you will, of the moon. But on the far side, we don't see that. There's very little molten material made it to the surface on the far side. And in fact, these basalt seas only account for about 1% of the surface, as opposed to about a third of the surface on the near side. And the reason for that is that the crust on the far side is thicker. And it's about twice as thick as the near side, maybe even 3 times as thick in some areas. And it's interesting. The obvious question is, well, why is that? And there's a number of schools of thought about that. Firstly, the moon, in this tidal locking that was described last night, this way that the moon orbits the Earth, and the same that tidal locking happened very, very quickly. Certainly within the first billion years, some estimates say within the first 100 million years. So in the very early stages of the moon, it was locked into the position that we see it today in terms of its face towards the Earth. So that would mean 2 things. Firstly, if that happened, as is suggested, about 3.9 billion years ago, or 4 to 3.9 billion years ago, the Earth at that time was still molten. It was still emitting a large amount of heat. And that would keep the near side of the moon warmer than the far side. And that meant that the far side cools quicker than the near side. And as it cools quicker, then it allows a thicker amount of minerals and material to build up. The second impact, of course, is that if it's facing the far side's facing away from the Earth, it's getting hit with more and more meteorites than the near side, and they then also add to accumulation of material and the thickness of crust on the far side. So there's been a few aspects of that. It's the near side heating from the glowing Earth, and also the impact of meteorites and the rapid cooling of the far side that has created this difference. And if we take a look at some of these very early images, which I think are quite interesting, in that there was no landing on the far side by these. These were largely flyby missions, except this first one, which was made in October 1959. And that was launched by the Soviet Union. It passed within just over 6,000 kilometers of the moon's surface at its closest approach. And it took some images there. Those were the very first images of the far side of the moon. But it was too weak in terms of the energy to transmit the images back to Earth from the moon. And it actually made a return journey to the Earth, not to land, but to go into back on Earth, but to orbit. And that allowed it to have sufficient energy to transmit 17 pictures of the far side of the moon. And these are some of the examples of those. You can see they're very grainy, so we don't see any of the features, of course, from our modern cameras. But you can pick out some of these features, particularly this area here that we saw in the very first image I showed you. It's very distinctive. The second image is from another Russian spacecraft that was launched in 1965. Closest approach, just over 9,000 kilometers. And that took a range of visible light photographs and ultraviolet photographs over about an hour. And it also actually played a part in a Martian project. And these are some of these images here. Again, not as grainy as the first ones, but again, still slightly fuzzy just by the nature of the technology at the time. And there's one image that did actually create some real stir back on Earth, and that's this one at the bottom right. And it was this so-called tower or feature here that was unexplained. And it was felt at the time, or there was some speculation at the time, that this was the built a city built by aliens on the far side of the moon. And if you Google that, you will find quite a lot of stories and images and speculation at the time about that, which makes it quite interesting. And of course, then the real modern images start with Apollo 8, which went behind the moon for the first time. And then emerging from the moon took this really iconic image in the bottom left here of Earthrise from the moon, which created, as you can imagine, a great stir, because that's the first time the Earth had been seen from space, from the far side. Well, tonight we did have some images by the team with their telescopes. They did manage to capture one or two images there, and this is one. I think this was taken by Gordon, and a second one taken by, I think it was Neil, took this one. Some real spectacular images there, which we'd hoped to show you live, but clouds in Caithness being what they are, that's not possible. We shall try again, I think, in later in the year to see if we can achieve that.
Keith, can I just butt in?
Yes, certainly.
That was perfect timing, because I think I'm probably going to get about a minute's worth of the moon live through thin cloud,
right,
before some thick cloud appears. And I think Christian is seeing it now and again as well. So let me try first, and
perfect.
How do I share? It's trying to pop in and out of view for the whole talk, but never lasting more than a second or two. Hopefully you can see that. I'm going to have to adjust the exposure because the cloud keeps affecting the view. So you can probably see that there's lots of cloud passing in front of the moon at the moment, but that's the live view from my back garden in Thurso. And as you saw from the photographs that were just shown, it was a fantastic view of the moon about an hour before we started. But that tends to be the thing doing astronomy in the north of Scotland. The clouds don't play ball. So I reckon I've got about another minute or two of viewing the moon. Christian, if you want to unmute and let me know how it's looking at your end.
Yeah, I can just see it.
I think that's feedback. It's probably just as well I wasn't speaking 20 minutes ago, because there was a blackbird in the garden going mental, I think, at me being here in the dark annoying it. So there you go. That's not too bad a view of the moon at the moment. Let me just zoom in a little bit.
I have an okay view now.
Excellent. How does your view look for the next 5 minutes or so, Christian?
Seems to be not too bad at the moment. I think there's quite a gap at the moment in my place.
Okay, so maybe what I'll do is, as I've got a pretty good gap, I reckon, for at least a minute, possibly a bit more, I shall try and give a bit of commentary, perhaps, of what is visible on the screen. So my apologies in that I will have to keep adjusting the exposure to adapt for the clouds. So just bear with me if I do that. But what I'm going to do is try and point out some of the features on the moon. So you'll see in the middle of the screen at the moment, there is a curved arc of mountains. So that mountain range there is the Montes Apenninus. And what you have is that whole arc round there is at the edge of an impact basin on the near side of the moon, and you'll be able to see there's lava plains here, nice smooth surface. So I think this is the Mare Imbrium, Sea of Rain or Sea of Showers, I believe it's called. The impact basin here is the Sea of Serenity. And if I just move the view a little bit, we can have a look at everybody's favourite. The Sea of Tranquility is this one here. And the Sea of Tranquility, of course, is where the Apollo 11 mission landed, and it landed round about this location here. So you've got Apollo 11 landed roughly there. Apollo 14, I believe, was about here, and the last mission, Apollo 17, was here. Now, going back, there was one landed at the edge of the mountain region, somewhere round about here. And I can't remember which Apollo mission that was, but there was also one there in amongst the foot of this mountain range. So let me just try and pick out a few other features. You'll be able to see here there's a crater with another crater inside it. And there's actually two craters inside. There's a large one there that's very obvious, and a smaller one there. Now, what that tells you is that the larger crater formed first, and then these two smaller ones formed afterwards. So as I mentioned in the presentation yesterday, you can tell a lot from the craters and their interaction when they happened. So that's my minute up. Unfortunately, the cloud has come in. So hopefully, Christian, have you got a view in Falkirk that you can share with us?
Yeah, just a bit.
So just to confuse things, I'm noticing on Christian's screen that he's got the moon the other way around. Clearly, it hasn't flipped in the sky in the last few seconds. It's just the way that the camera and telescope is oriented, pointing towards the moon. But what you'll be able to see there is that the moon is currently half of the disk is illuminated, and so that's referred to as the first quarter moon. And you'll be able to see some of the darker zones there, and the lunar mare. And I pointed out a few of them, so you can probably fairly clearly see the clouds are getting in the way just as I'm trying to describe something. But hopefully you were able to see the dark zones there that I talked about, the Sea of Serenity and the Sea of Tranquility, which is roughly in the middle of the moon there. And you'll also hopefully have been able to pick out, I don't know, Christian, are you able to share your screen so it's a little bit bigger?
It should be shared now, no? Oh, I don't have it on the screen. I have directly the stream connected to the my video feed.
Ah, right, okay. So what you can probably see is along the boundary between dark and night on the surface of the moon at the moment is what's referred to as a terminator, and it's easier to pick out the detail there because the low angle of the sunlight, it generates shadows that give you an idea of the shape of the surface of the moon at that point, and it makes the mountains that I showed you and the craters far more prominent when you look at it. So most of the time when amateur astronomers have a look at the moon, they try not to look at the moon when it's a full moon because there's less detail tends to be visible at that time. And a few days before first quarter, which is tonight, and a few days after it is probably the time that you get the maximum benefit from the shallow angle of the sunlight hitting the lunar surface when it comes to doing observations and photographing the moon. So I'm completely clouded out here now, so I think it's probably safe to say that the observations live stream from Thurso is now at an end. It's good to see that Halkirk has managed to last a little bit longer out of the cloud, but maybe the best thing to do while we've still got the view in Halkirk is if we nip to questions and see if there's any there that we can answer.
One question here: has anyone observed a real-time lunar impact? That's a good question.
I can probably have a go at that one.
Go ahead.
Because nowadays there are lots of amateur astronomers pointing telescopes at the moon, doing observing, and probably more importantly, actually capturing video feed of the moon. What has happened over recent times is there have been a number of impacts actually captured on video, and it's captured by amateur astronomers, not by professionals, because the professional astronomers tend not to be pointing telescopes at the moon. Their telescopes are not designed for that, the ones on Earth, and they can get far better data on the moon by sending spacecraft there, collecting rock samples, bringing it back, looking at lunar reconnaissance, orbiter type images. So they have access to data via that means, but amateurs are somewhat limited to pointing their telescopes at the moon from their back garden. But the big advantage is this different type of observing has allowed a number of impacts to have been recorded. And I believe some of those impacts have then been followed up by the Lunar Reconnaissance Orbiter. Next time it goes over that zone, it compares the detail in the image captured after the impact with the one it took previous to it. And they have actually managed to capture the change in the lunar surface, the new crater that has formed on the LRO images that was captured live by amateur astronomers using cameras attached to their telescope. So quite cool, a little bit of, I suppose, citizen science there. They've provided observations to the professionals who have followed it up. And of course, what they can then do is do some work viewing the crater, perhaps doing some analysis to see what information that can give them about the surface of the moon. So quite exciting that amateurs can manage to capture things that the professionals can then follow up. Okay, so that was quite a long-winded answer to a very simple question, but the answer is yes, it has been captured.
Oh, that was good. That was
like a geology one to me, Keith. So I suspect that one's definitely.
Oh, right. I just lost my screen for a second there. Let me just have a read of this. How large was the likely? So when the lava poured out to form a smooth area in the impact areas, such as the Sea of Tranquility, how large was the likely damaged crustal area through which the lava flowed? That's a really good question, because it's if we think of it's very difficult to determine is the short answer, because a lot of the lava and the seas that were formed by volcanic activities, and not all formed by impact craters. So I think so there's a mixed form of mechanisms by which the seas can be formed. If we think of, we've got an upper limit, if you will. If we think of that large impact basin on the south side, or sorry, the far side of the moon, the South Pole, then that gives us an extreme case of the size of the asteroid. The others, because clearly the actual impact crater has been obliterated by lava flow, it's very difficult to determine the size of any impact, and of course the lava flow would have actually removed and infilled the impact area. So it's actually quite difficult to determine just those early origins or the origins of those early lava basins. Gordon, this is one for you. Is it possible to zoom in and see any American or Russian leftover landing units?
The simple answer is with any telescopes operated on the Earth, or even the Hubble Space Telescope, no, it can't see that level of detail. But if you once the presentation from last night is available online, I'm not sure if it is yet, but if it isn't, it will be in the next day or two. Halfway through the talk, there are some images taken by the Lunar Reconnaissance Orbiter that shows that very detail for each of the 6 Apollo landing sites. So the answer is yes, we can see it, but only from the photos taken by spacecraft in orbit, not by telescopes on the Earth or even in orbit around the Earth. Okay.
That's very good.
And the next one looks like a rock type one. So again, back to you for that one, Keith, I think.
Thanks. Well, you know quite a lot about meteorites. In fact, you've got some samples, haven't you? So I'm interpreting. I'll let you come in on that in a minute, because I know you've got a bit of a collection there. The nature of the meteorites that are found on the moon and found on Earth, well, the origin of them is typically the same. So the nature of the meteorites, from whether it's from asteroids or from Mars, or even speculatively from Mercury, there's no reason why they should be different from that sense than that are found on the moon than are found on Earth, because clearly they impact both bodies as well. The more they would be better preserved on the moon, potentially, because of lack of erosion and the weathering that we see on Earth. And we do, of course, have meteorites from the moon that occasionally fall on Earth, and I just can't quite remember just offhand one example of one that was found, which is very high in that plagioclase, so very high in the crust. And I'd have to look that up. I can't remember which one it is. I don't know, Gordon, if you can remember any more details on that. It's a while since I read about that, but in essence, we're still seeing the same type of meteorites, some carbonaceous chondrites and some iron nickel meteorites as well. Gordon, I don't know if you've got anything.
I don't really have anything to add to that, other than if Tim didn't manage to see Dr. Mike Sims' talk
Yes.
for the Science Festival on meteorites, it's online now, and I would highly recommend it. I can pretty much guarantee that Tim will be thoroughly engrossed with the amount of detail in it. But I don't have anything to add to what Keith said regarding this question. The meteorites, by and large, in the solar system all come from the same pool. So the bits floating around in space that have been there since the early part of the solar system, wherever they land, they're going to be similar. The only difference, obviously, is that on the Earth we have some meteorites from the moon, and I'm not sure, but I'm kind of guessing that there might be some rocks on the surface of the moon that came from the Earth in the early stages, when a lot of the bombardment was happening 3.5, 4 billion years ago. But by and large, there won't be much in the way of difference of meteorites that's landing on the moon nowadays compared to what we see.
Yeah, that's a good tip for that. Looking at that meteorite talk as well. That's excellent. Very worthwhile looking at that.
Yep.
Is there a space station on the moon? Well, not yet.
Yeah. And I would probably recommend, like I did last night, for those that are interested in learning a bit more about the plans for going to the moon, you could start with Googling the NASA mission Artemis, which will be sending people back to the moon probably sometime this decade. And as a follow-on from that, I think the plan is that they're going to look to have some sort of moon base produced, but I suppose one step at a time is the way to take it. So that's going to be a bit off yet.
And although Russia and China have intimated their intention to establish a moon base at some point, but I think that's just an ambition at the moment. Right. What is the moon's atmosphere? Good question.
Nothing much, I think, is probably the answer.
It is. It's a good question, though, because you know, if we take an example of Mercury, about the same size of the moon, also very, very cratered. That was thought not to have any real atmosphere at all, and I mean, the moon doesn't have anything, but it was discovered at the recent Mercury probes that actually Mercury does have a very thin atmosphere, quite an unusual one, mainly of sodium vapor. So it's surprising how planetary bodies which look completely barren with no atmosphere actually can have some, not an atmosphere in the way we would describe it, but a layer of vapor or gases that are very, very thin. And even Pluto, the probe that went to pass just flew by Pluto, and its final image turned back towards Pluto, back towards the sun. And if you look up that image, it's the Pluto itself, is dark, but there's a thin blue line around it showing an atmosphere. We don't know what that is, but it's just quite extraordinary that even those bodies that look completely barren can have an atmosphere. So it's a question that's worth asking, because the answer isn't always obvious.
Okay.
I think
that's all the questions answered, is it?
It is. Oh, you've still got an image there.
Yeah. So I suspect that's us done. But before we hand over to Garance, on behalf of Caithness Astronomy Group, I would just like to thank the festival for getting us involved. We've been delighted that we've been able to contribute this year. And I think a special thank you to Nicola for doing all the organising she does and keeping us right, because it's no mean feat to pull all of this together. So thank you to everybody involved in doing the organising as part of the Science Festival. And I think that's a good point to hand over to you, Garance.
Oh, thank you. And thank you all so much at Caithness Astronomy Group. The work you've put in for this Science Festival has been absolutely outstanding. The presentations have just been fabulous and inspiring. Thank you. And tonight was no different. Another wonderful presentation. Thank you so much. And I'm just going to do a little bit shameless plug-in before I let you go this evening. So on Wednesday, carrying on with energy, we have Magnus Davidson from the Environmental Research Institute will join us to explore offshore wind potential found around the coast of Caithness and discuss new and existing developments can benefit us at a local, regional, national and international level. He'll also be taking a look at the plans for the Pentland floating offshore wind farm off Dounreay and onto the wider potential for the new ScotWind leasing round. That's going to be very interesting to find out all that information. Then on Thursday, we're heading off back into space and we'll be joined by former astronaut Digger Carey and his wife Cheryl for a reflective and entertaining look at how they built a life and a family together. After meeting in high school, they achieved liftoff in the military and then soared with NASA. But it wasn't always smooth sailing for them. Learn the highs and lows of serving your world with pride and keeping it all together whilst raising a family. Questions and answers will be to follow on that session. You can find out the full details of what's going on for the rest of the Science Festival at science03.org. And thanks again for joining us this evening. And thank you again, Caithness Astronomy Group. Wonderful. Thank you very much. Enjoy the rest of the festival. Goodbye.